Today's topic for discussion is Introduction to Software Vulnerabilities. In this topic, we'll try to define what is the software vulnerabilities, what is the process of infections. Suppose that you have written a program and it gets infected by the virus. What is the process through which it gets infected? We try to explain in detail. We'll also talk about different kinds of software vulnerabilities. We will also try to classify different kinds of vulnerabilities, and then we'll explain one kind of or one type of software vulnerabilities. But let's recall what we have discussed prior to this topic, and our discussion was around the encryption technique. Encryption is a technique which used to keep sensitive and personal information safe, such as passwords. It is a process of converting the original information known as plain text into an alternative form known as ciphertext. So the input to encryption is your original information, and sometimes we call it plain text in encryption techniques. So plain text is the original data which requires to be encrypted, which you have to keep safe from hackers. So this is called plain text, and after encryption it gets converted into a ciphertext. So only authorized person can decipher a ciphertext back to the plain text and access the original information. This is what we have discussed, that the original information does not gets transmitted in that form. It first gets converted into the ciphertext. Widely used encryption techniques today is asymmetric and asymmetric encryptions, or you can say that the encryption techniques are basically two types: symmetric and asymmetric encryption techniques. The name derives from whether or not the same key is used for encryptions and decryptions. So the difference between the two, whether we are using the same key or not. Asymmetric key encryption is considered to be more secure compared to symmetric encryptions, as it uses two keys for the process. So it's more complicated. The asymmetric key encryption scheme has 5 elements. It's 5 components. One is the plain text. This is the original intelligible message or data which is fed into the algorithm as input, which has to be transmitted from one system to another systems. The second is encryption algorithm. The encryption algorithm performs various substitutions and transformations on the plain text. There is a secret key. Secret key is also input to the encryption algorithm. The key is a value independent of the plain text. So we are giving two kinds of input to the algorithm. One is the plain text, and second is the secret key. The key is a value independent of the plain text. The algorithm will produce a different output depending upon a specific key being used at that time. The exact substitutions and transformations performed by the algorithm depends upon the key. Asymmetric key encryption, also known as public key encryption, is a form of encryption technique where the encryption key, also called the public key, and the corresponding decryption key, also called the private key, are not the same. In the symmetric key, both the key is the same for encryptions and decryption, but here key are different. In asymmetric key encryptions, users typically create a matching pair and make one public while keeping the other secret. That way it's a bit more complicated compared to symmetric key encryption technique. Now move to our topic, software vulnerabilities. First let me define what is the term vulnerability. The term vulnerability is being used here in context with computer security. So the vulnerability might be in different contexts, in different disciplines, but here our focus is more on the computer security. At a later stage, we'll try to differentiate between computer security, network security, information security. Sometimes people call it cyber security. Sometimes people say ICT. So all these terms will be defined at a later stage. Although there will be some overlapping, but there is a clear-cut distinction between all these terms which I listed right now. So right now we are talking about computer security. The term vulnerability refers to some violation of a security policy. So any organization defines what to be protected, what is not to be protected, who is authorized to access, who is not authorized, and even if one is authorized, what access he has, whether he can read or write or modify or take the printout. So every organizations, for every kinds of information, primarily the sensitive data, they define the policy, what we call them security policy. So if there is some kinds of violations of the security policy, then it is vulnerable or the software is vulnerable. Vulnerability occurs due to the weak security rules or due to some security problems within the software itself. It might be because of outside, or it might be the faulty software which has been written, and that also might cause vulnerability in the software. Theoretically, all computer systems are having some kinds of vulnerability. We'll see now that when you develop a software, you have to meet the target. Software is quite complex. It has to deliver on a particular date. So not all the, sometimes some mistakes, some types of faults remains unattended, and that is the reason the software becomes vulnerable. Seriousness of vulnerability depends upon the level of damage it does to the systems. Now, what damage it will cause to the software or to the system if it is vulnerable? It includes loss of information, which can reduce the value or usefulness of or credibility of the system. It permits an attacker to run commands as another user. One example of a software system is vulnerable, security is very weak. Permits an attacker to provide to access data in spite of no access permission for that data. Permits an attacker to disguise as another entity. Permits an attacker to conduct a denial of service. So these are the few activities which takes place if the software is vulnerable. And let me, the new terms we have, new term has appeared here, and it is written in the last line is a denial of service. So let me define what is a denial of service attack. This is a quite common attack, and we'll keep on talking about DOS in different contexts. To start with, denial of service attack is meant to deprive legitimate users, that is employee, members and account holders, of the service or the resources they expected. So basically here is a kind of attack, a kind of cyber attack meant to deprive legitimate users, that is employee of the organization, which is legitimate user, they have access to the sensor, some member of the software group or any account holder, of the service or resources they expected. Shut down a machine or network, making it inaccessible to its intended user. So basically what happened, that a person who is legitimate user in this system and not able to access the resources, and that is called denial of service attacks. How it happens? DOS attack does this task by overloading the target with traffic or sending the information that triggers to crash. So sometimes they will send more and more information, and that is why it causes the crash of the systems now. And the legitimate user is not able to access the system. So that is called denial of service. So denial of service is a kind of attack in this system, due to which a legitimate user, could be employee, could be members, could be account holders, is not able to get the required services from the system. A software vulnerability can be defined as a flaw present in the application software or in an OS. So operating system, it can happen, software vulnerability can happen in the application software, and it also can happen in the operating system. So there are two kinds of software we can classify. One is application software, that's something you write most of the time for any organization, for improving the performance of any organization who try to computerize. You can write accounts application, you can write other education software. So all the software will be part of application software. And there is a software called operating system or compiler. These are called system software. They control these systems. So OS, Unix is the operating system, Linux is operating system, Windows is operating systems. Mobile also we have there is operating system. So they control the resources of these systems now. So it can be a flaw in both application software which a programmer usually develop and the operating system which controls the resources. Software vulnerability is a problem that is potentially so dangerous that it threatens the proper functioning of the computer system. So this problem has to be addressed. Because today operating systems and application software are very complex in design due to inclusion a lot of functionalities, it's difficult for a vendor's development team to create a software without any flaw. So that is why it happened. That is, it contains lots of functionality and some other constraints are there, due to which some problems remains in the software in the release. It can happen in operating system, it can happen in application software. Because the software development is not a perfect process or a science. So basically what I want to explain here is that same software can be written in different way by different programmers. It's basically art. You not necessarily that you will suppose that for writing a program one can use a different kinds of algorithm, someone can use another kinds of algorithm. They have a different style of writing a program, someone has a different style of programming. So it's not exact science or a perfect process. Programmers work under many constraints: strict product and delivery schedule, shortage of experienced professional to write codes, etc. This is another reason that they have to deliver the product on a particular date. There is shortage of experienced professional in the organizations. To write a good code, efficient code, optimized code. Getting a result is one thing, but writing the optimal code which takes less number of lines in a program, but be very efficient codes. It means that gives you very good performance. Not everyone is able to do it in less period. This is the constant now. As a result, developers may not be able to identify all the flaws before an anticipated release date. Many companies release initial version of a product, and then when they find problems, they fix them with new kinds of updates, and sometimes they call it patches. So they release because they have to release, they have to survive in the market. And when later stage, when someone points out there is a flaw in the software or they themselves find, then they release a new patches to modify the bugs left in the system. Software companies cannot support their products forever. This is another issue one has to be concerned about. But to stay in business, they have to keep improving programs and selling the updated versions. Companies sometimes stop issuing new patches for the older version after some amount of time. So these are the issues one has to deal with related to software vulnerabilities. So any company, any organizations which purchase the new kinds of software or developing new kinds of software is quite complicated. All these constraints one has to address them. So vulnerability exists in all types of software. Several versions here, few examples which I am taking, publishing the books and the magazines, that several versions of MS Windows OS were open to the attack. The popular open source web browser called Firefox has had more than 100 vulnerability identified and scored every year since 2009. 15 different vulnerabilities have been identified in Microsoft Internet Explorer browser variants since the release of this product in 2017. And this is not only, this does not confine only to browser and operating system, but it is applicable to almost all software, whether it is another database software or another types of operating system or any other kinds of complex software. So it is a common practice that some bugs are left and later on they are discovered, and the company releases a new patches to address these kind of problems. So almost exists in all kinds of software, and it happens with all kinds of software developers. As software vulnerabilities are discovered regularly, and ideally vendors release patches, it is critical to install these patches as soon as after they become available as possible, because again new kinds of patches might be coming. Both Mac and Windows PC provide an automated patching capability as long as you allow it to do so. So as long as the individual allow to do this one, they automatically update your software in the background, so in the process. The kind of software is popular as, so the software which is vulnerable, it is also called malware, and I will try to define what exactly this malware is. So this kind of software which has a vulnerability is popularly known as malware, which is acronym for malicious software. Malware does nothing, depends upon what kinds of malware we have. Software has access into this system. Some does harmful, some does not do more harm to these systems. There are several types of malware, each of which has different goals and follow different approaches to propagations in the computer system. So this is way different kinds of malware is classified, how they propagate in the systems. Some stay dormant for a long time, some immediately starts acting. Now we explain to you one very important concept which you have to understand. How does really these kind of malware works or malicious software work, how they infect the systems. To understand how a malware infects a system, let's understand how does a PC, old system, so we are talking about the old computer, old personal computers, how they used to work. So on booting, the system carries instructions which are stored in the read-only memory. So we have a RAM, we have a ROM, we have different kinds of ROMs only. So some software permanently burnt into read-only memory. So let me repeat one sentence. On booting, the system carries instructions which are stored into the ROM. The first such instruction is called the power on the self test. This is instruction. The next is booter step process of reading the boot record and loading the disk operating system. We are explaining how the earlier personal computer used to work. So this is very important to understand how the malware affects the system. If the booting process is successful, system prompts is displayed on the machine. So when you get a system prompt, the booting has been successful. The infection starts as soon as a computer system boots them on infected disk or executes an infected program. Whatever types of malicious software are present gets activated, which immediately begins to spread throughout the system. So once you get infected, then start into the system, from one file to second file to third file. Interrupt mechanism is another important and related aspect. So to understand this one, let's try to understand what is the interrupt. And all input output tasks on a PC are carried out by the interrupts. So 2-3 examples here is, let us say a user wishes to type something and presses the appropriate keys, or clicking the mouse, for example, are treated as interrupts. The moment you click your mouse or moment you hit a key, so it automatically interrupt is generated. Through this interrupt, system is able to understand what action has to be taken now, or where from action has been initiated by the user. The main memory has specific procedure or routines to handle these user requests or interrupts. So the interrupts is basically user request, and depending on what kind of request you have made, there is separate program or procedures or routines stored into the computer's memory to handle these requests. So the for mouse might be separate kinds of interrupt, separate kinds of routine is there. Through keyboard you have a different kinds of routines are there. Or you insert a pen drive, there might be different kinds of interrupt routines are there. So depending upon what action, input output action you have taken or user have taken, the corresponding procedures are activated. The program that provides the services to the interrupt request is termed as interrupt service routines, which are stored in the memory with their addresses in a tabular form. Interrupt request activates an interrupt number for the routine. So they don't they simply number is generated with each kind of interrupt, and that at that number routine and that is basically that number is for the routine address where routine program is or whether the procedure is stored. When an interrupt request is made, the CPU looks up the table and executes the required routines and transfer the control back to the program. The contents of the ISR address table being in the RAM is vulnerable to modification by the user program. So these routines are also vulnerable for modifications, and virus does modify these kinds of tables where they have interrupt service routines are stored. So when floppy disks were in use, so whole our discussion about the infection process of infection was somehow related when we used to, operating system was stored into the floppy disk and used to boot your system with this floppy disk. Now things have changed. The malicious software spreading through the corrupted floppy disk, but now they spread through the internet, which is a main source for this malicious program. It can spread quickly, affect all the system in organizations within a minute, and make information vulnerable to users. This can create a huge loss for the organizations now. A software vulnerability is the only aspect of computer system that allow for breaches in the security policy, already discussed, often caused by software bugs. So we'll try to find some reasons now, what kind of problems, what are the features, or basically what kinds of the region, caused by the software bugs. So we'll try to find out that, let's go into a little bit more details what it affects, software vulnerability, how it affects the systems. So the last line is important, often caused by software bugs, that is unchecked buffer or software features executable attachment to the email. These are the regions through which software vulnerability takes place in the system. Now we'll talk about some of the types of security vulnerability. Computer security vulnerability can be divided into numerous types based on different criteria, such as where the vulnerability exists, what caused it, how it could be used. Some broad categories of these vulnerability types include network vulnerability, operating system vulnerability, and password vulnerability. There are three basically primarily defined, but not necessarily if you read the literature, you find some other different types have been discussed now. But we'll confine to these kinds of vulnerability and more on network and operating system. The network vulnerability, let me just explain you what exactly. These are issues with a network hardware and network software that exposes it to the possible intrusions by outside party. Examples include insecure Wi-Fi access points or poorly configured firewalls. So network vulnerability are related with the network hardware and software. Firewall is part of the network hardware, you can say. And the operating system vulnerability, these are vulnerability within a particular operating system that hackers may exploit to gain access access to an asset that OS is installed on, or to cause damage. Example include default super user accounts that may exist in some operating system installs, and hidden backdoor programs. So these are the few, and many, one can think of many other components of operating system which gets affected. The common software vulnerability, this is what is important part of today's discussion. The most common software security vulnerability include buffer overflow, missing data encryptions, OS command injections, SQL injections, misauthentication for critical function. So there are endless software vulnerability are there, but we'll talk about only just few in this and the next slide about buffer overflow, OS command injections, and SQL injection, and some other. A buffer is a sequential section of memory allocated to contain anything from a character string to an array of integer. So RAM, basically you can say the buffer. The buffer overflow or buffer overrun occurs when more data is put into the fixed length buffer than the buffer can handle. So you have overloaded the buffer. You have stored more programs than it can handle. The extra information which has to go somewhere else can overflow into the adjacent memory space, corrupting and or overwriting the data held in that space. And the overflow usually results in a system crash but it also creates the opportunity for an attacker to run arbitrary code to manipulate the coding errors to prompt malicious software. So this one common kinds of the software vulnerability is the buffer. So they put more data into the buffer than buffer can handle. So the remaining data moves to the adjacent buffer, and that can cause the crash of the system, or any other thing can happen in the overloaded buffer. Many programming languages are prone to the buffer overflow attack. The extent of such attacks varies depending on the language used to write vulnerable programs. Example, code written in Perl programming language or JavaScript scripting language is generally not susceptible to buffer overflow, but the buffer overflow in a program written in C, C++, Fortran assembly could allow the attacker to fully compromise the targeted systems. Different types of buffer overflow attacks. One is called the stack overflow attacks, and second heap overflow attacks. This is stack overflow attack is the most common type of buffer overflow attack, and involves overflowing a buffer on the call stack. The heap overflow attack is the type of attack which targets data in the open memory location, such as called a heap. A stack overflow refers specifically to the case when execution stack goes beyond the memory that is reserved for it. Buffer overflow refers to any case in which a program writes beyond the end of memory allocated for any buffer. What we have discussed here, we have given you various kinds of definition, what exactly is software vulnerability. We have defined different kinds of classify the software vulnerability, and some of the basic common software vulnerability is buffer overflow, SQL injection, OS command that will be taken up at later stage. Best way user can protect themselves is to regularly install software as soon as updates are available. Thank you.